Hello, we are going to talk about different transformations today. So just a reminder, transformations move a graph someplace else. I have a table that I'm going to show you that's just going to kind of outline all the transformations that we'll talk about. So on the left will be the transformation. In the middle will be what the equation would look like. And then on the right side will be like a verbal description of how the graph will change. So first one is we're going to have vertical shifts. Vertical shifts mean we go up and down, hence vertical. So in an equation, we would have our equation or our function, and then we would have a plus c. If it's plus c, we're going to go up c units. Oops. We can also have our function minus c, and that means we're going to go down c units. Okay, remember c stands for constant, so it'll be a number. Okay. Next, we have horizontal shifts, and horizontal means we're moving left and right. If you have your function, within your function, you have a minus a, that means you're actually moving to the right this many units. And if you have a plus a on the inside of your function, you're going to move left a units. Okay. Next, we have two different reflections. So the first reflection, we would have a negative outside our entire function. And this is going to signify a reflection across our x-axis. If our negative is on the inside of our function, that means we're reflecting across the y-axis. Okay, and we'll see a couple of, or the difference between those in a minute. Okay, I have two more transformations before we look at examples. Okay, we have vertical stretches and vertical compressions. That means we are either going to it's going to look like we're going to pull from the top and bottom, or we're going to push on the top and bottom of our graph. So a vertical stretch and compression is signified by a times our function. If a is greater than 0, that will be a stretch. If a is between 0 and 1, that will be a compression. Okay. So this would be some sort of fraction will vertically compress. So I'm going to start with a really basic example. Here we have to graph and state our transformations between these two functions. So we have y equals x, which is just a line, and then y equals x plus 2, also a line, but it's shifted. So if we use our table that we've just created, here's our function, so that would be our f of x. Here's that f of x function again, but this time we've added 2 on the outside. So if we think about our table, this we're assuming is going to be a vertical shift up 2 units. But I went ahead and graphed these. The black line is y equals x, and then the pink line is y equals x plus 2. And it does indeed appear that we took our black line and shifted it up 2 to get that pink line. So it is a vertical shift up 2 units. We won't always be asked to graph. Sometimes we're going to have to figure out the transformations just based off of the equation. So here we have y equals the square root of x and then minus 7. So square root of x is our function. That would be the f of x. And we have a minus 7 on the outside, which means we are going to have a vertical shift down 7 units. Okay, this one looks a little different. It's y equals the square root of x plus 5. So this time that plus 5 is on the inside of my square root, which means it's inside. So we're going to have a horizontal shift. If you look back at your table or your notes, a plus 5 moves it 5 units to the left. So horizontal shift, 5 units left. And I did a really, really rough sketch of this graph compared to the parent function. So our parent function is just y equals square root of x, and it's centered at the origin, and then increases. Y equals square root of x plus 5, we said, should be shifted to the left 5 units, and it is indeed. So graphically, that's what that would look like. Okay, here's another function. We have y equals negative square root of x plus 4. So this time we're going to have two transformations going on in the same equation. I always move left to right, so this negative is on the outside of our function, so it's going to be a reflection over the x-axis. And then we have this plus 4 on the outside, so vertical shift up 4 units. Okay, one more, and then I'm going to have you guys do one on your own. So we have y equals 1/2 times the square root of x minus 1. So again, there's two different transformations going on. First of all, we have that half on the outside. That half is going to be multiplied by our function. So it's a vertical either stretch or compression, and we have to decide what is that a value. Well, our a value is between 0 and 1. So this would be a vertical compression. Then we move on into this x minus 1. That's a horizontal shift to the right 1 unit. I want you guys to use your table and tell me what transformation or transformations occur in this equation.